Good afternoon students. Today we are going to discuss about electronic configuration of 5th, 6th and 7th period element. Students, आज हम लोग इलेक्ट्रॉनिक कन्फिगरेशन के बारे में स्टडी करेंगे 5th, 6th और 7th पीरियड के एलिमेंट्स की. Students, earlier we have seen about the electronic configuration of 1st, 2nd, 3rd and 4th पीरियड. इससे पहले हमने फर्स्ट, सेकेंड, थर्ड और फोर्थ पीरियड की इलेक्ट्रॉनिक कन्फिगरेशन को देखा, वेयर वी हैव सीन दैट फर्स्ट पीरियड बिलोंग्स टू 2 एलिमेंट, सेकेंड पीरियड बिलोंग्स टू 8 एलिमेंट, देन थर्ड पीरियड बिलोंग्स टू 18 एलिमेंट एंड फोर्थ पीरियड बिलोंग्स टू 18 एलिमेंट. नाउ वी आर गोइंग टू डिस्कस अबाउट द 5th, 6th एंड 7th पीरियड एलिमेंट. So students, coming to the topic, that is electronic configuration of 5th period element. So here you can see that students, like the 4th period, 5th period also contains 18 elements. In 5th period also there are 18 elements, and since only 9 orbitals, that is 1 5s, 5 4d and 3 5p are available for filling of electrons. Okay. And students, talking about the elements, so it begins with rubidium having atomic number 37, in which one electron enters 5s orbital. Inner core is krypton, that is having 36 electron, and the next electron enters to 5s orbital. Here you can see students the rubidium, okay, inner core, that is krypton, which is having 36 electron, and after that the new electron will enter to 5s orbital, that is 5s1. After this there is a strontium, which is having 38 atomic number. So for krypton, inner core is having 36 electron, and the 2 electron will enter to 5s orbital, making it krypton 5s2. Okay. And after this students, what happens, the filling of 4d orbital starts, and it starts from yttrium, that is Z is equal to 39, and ends to indium, that is Z is equal to 49, and ends to xenon also, which is 54. So students, talking about the D block elements, so here you can see the 4D series starts from yttrium. So yttrium, zirconium, niobium, molybdenum, technetium, rubidium, rhodium, palladium, silver and cadmium. So you can count, these are basically 10 elements. Okay, so the 4D series correspond to 10 elements, and you can see the filling of electron, the electronic configuration basically as for yttrium, the new electron will enter to 4d1. After that it will enter in the same cell, that is 4d, having 4d2 configuration. Then in case of niobium, you can see it is krypton, the inner core, then 4d4 and 5s1. After this there is molybdenum, that is krypton, 4d5, 5s1, and in this manner you have to give the electronic configuration of 5th period element. Okay, and it ends with cadmium. So here you can see that it is 4d10 and 5s2, and in case of silver it is 4d10, 5s1. Students, you know very well why this is happening, as earlier we have discussed about the half filled and fully filled orbitals stability. हमने देखा था कि हाफ फिल्ड या फुली फिल्ड ऑर्बिटल की स्टेबिलिटी के बारे में. तो हम देखेंगे, अगर हम सिल्वर की कन्फिगरेशन करते हैं तो ये होनी चाहिए थी क्रिप्टन, विच रिप्रेजेंट्स 36 इलेक्ट्रॉन. इसके बाद हमारी कन्फिगरेशन जो थी वो थी, चूँकि 3D की एनर्जी लोअर है, so 5s2, sorry 4d, wait, 4d and 5s. Okay, so we should fill it in the manner that is 4d9 5s2, but this pattern is wrong, because in case of 4d9 the orbital, that is half filled orbital, or you can say the unfilled, there is unfilled orbital. Okay, and this is unstable, so we can make it to 4d10, which is completely filled and more stable, and we will keep 5s orbital as only one electron. So this will be the electronic configuration in case of silver. So for silver it is exception, for molybdenum it is exception. Okay, now students, let's talk about the sixth period. Okay, students, after you can see here, after cadmium there starts the p block element. Okay, as there is 3 p shell, so for this there is the element like indium, tin, antimony, tellurium, iodine and xenon. So here the pattern is very clear, that is the very first electron enters to p1 having 5p1 configuration, then for tin it is 5p2, for antimony it is 5p3, for tellurium it is 5p4, for iodine it is 5p5 and for xenon it is 5p6. Okay, now students, talking about sixth period, so it corresponds to filling of sixth energy level, that is n is equal to 6. Since in this period only 16 orbitals are there, students, basically in this period, that is sixth period, there are 16 orbitals, so it can maximum accommodate 32 elements, but basically 32 electrons, which will represent that there will be 32 elements. Okay, and these orbitals are 1 6s orbital, 7 4f orbital, 5 5d orbital and 3 6p orbital, and these are available for filling with electrons. Therefore sixth period contains 32 elements. And you can see, students, the elements goes on like in the very first, the cesium and barium belongs to the s block element having the configuration xenon inner core, which represent 54, then 6s1. After that barium correspond to xenon inner core, which represent 54, then 5s2, and after this the d and f block orbitals fillings takes place. So in this manner you have to give the electronic configuration of sixth period element. Okay, and students, there are basically the 5d series and also the inner transition element, inner transition element. Okay, here comes the inner transition element. And students, talking about the seventh period, so similarly it corresponds to filling of seventh energy cell, that is n is equal to 7, and like sixth period it also contains 32 elements corresponding to filling of 16 orbitals. Okay, that is 1 7s orbital, 7 5f orbital, 5 6d orbital and 3 7p orbital. What I am saying is, student, I am saying that there is one orbital which is 7s, there is, you can say, 7 5f orbitals, there is 5 6d orbital and there is 3 7p orbital. Okay, so this is all about the orbitals. And so maximum, so as we are seeing that there are basically 7 5 12 3 15 1 16. Okay, 16 orbitals are there, so maximum electron that can fill are 32, and hence there are 32 elements in the seventh period element. Here also, students, there will be 2 s block element, there will be 14 f block element, there will be 10 d block element, and there will be 6 p block element. And what are the elements? Let us see. Sorry students, the page not came yet. You can see here about the seventh period. There is francium, radium. Okay, these are belongs to the s block. Then here comes the actinium series, basically called as actinoid series. So in the actinoid series there are thorium, palladium, uranium, neptunium, plutonium, and the series hence go on. After this there comes the d block series, and after this there comes the p block series. So this is all about today's lecture. In our next lecture we will be discussing about the basic features, okay, derived from here the electronic configuration, that is whom we call as s block element, whom we call as p block element, what are d block element, what are f block element. This is all about today's lecture. Thank you class.